I'm going to talk about two different topics, two different set of tools, the discovery tools and the calculator plugins. So what happened with the discovery tools since the last UGM? Our work was mainly focused on speeding up the current similarity search, and the aim was the main use case was that we wanted to do a lot of similarity searches as fast as possible, and the result of this is this new tool called MedFast Similarity Search. It comes with lots of different tools. So it's based on the so-called fast descriptor generation. So you can generate ChemAxon descriptors and different other descriptors really fast. It also supports different lookups, so the most and the n-most similar lookups. And what I'm going to do later is the so-called overlap analysis for large molecular sets. It's also easy to work with it because you can directly upload your structure files. And currently it's just an API toolkit, so you have to have some programming capabilities to use it. But we also provided a command line application, a NIME, a node, and also a web UI prototype. The different exposed APIs are now available in GChem, so the MedFast Similarity Search, the Overlap Analysis API, the Clustering API, and the Descriptor Generation API are all available now in GChem, so you can try it. And before I go to the demo, I want to mention two things. The first is the performance benchmark, so you might ask how fast this tool is. And here are three data. So we can say that it is able to generate in about half a minute 1 million descriptors. On average, it is able to do one comparison in 1.5 nanoseconds. And for really large data sets, for 1 million times 1 million compounds, it is able to perform the overlap in about 30 minutes. Yes, I also put here a REST API example here, so it is also available now as a REST API, which will be available in Marvin Live later this year. And I put here two demos, which you can also find at our demo site outside. So please come and we will show you the details. The first this video demonstrates a very nice visualization of the overlap results. In this case, you can see some kind of histogram representation of the distribution of the hits, while the second is also a very interesting and very nice representation of the hits. So it's like gives you some kind of map which can be enlarged, and the hit pairs can be viewed as you zoom in the different parts of the map. Now I would like to talk about what happened with the calculator plugins. These are the other huge group of tools of the group. Yes, so for those who might need some information, ChemAxon calculations are a set of high-quality chemical tools. So basically, we provide a different set of descriptors for everyday chemical screening or chemical work. So we can calculate high-quality pK, log-P, log-D data. We can generate tautomer sets, stereoisomers, conformers. We can analyze, as I will show you later, stereo features of molecules. And we have a fairly new plugin, the solubility, which can predict solubility in water. All these functionalities are available in the main ChemAxon product, so you can find them in Marvin, JChem for Office, as NIME nodes, as a command line, in command line tools in Szisz Calc, and also as different chemical terms function. Our fairly new predictor, as I told, is the solubility predictor, which was released last year, and this year we also released a NIME node. So now you can put that node into your workflow and calculate solubility. With that, it's based on a very simple yet very effective so-called fragment-based method, which I'm going to go into detail if you are curious at the demo side. I put here just a very short user feedback. So for internet data sets, it gives quite good but acceptable results. However, in general, for general data sets, I can say that it highly outperformed our other solubility predictor competitors. The next development I would like to talk about is for one of our main predictors, the pK calculator. We focused last year on fine-tuning our pK model. You can see two main results. On the left side, you can see Szisz, two molecules with different geometric isomers. Now we are able to consistently distinguish between the cis and trans isomers and predict the correct pK values for both isomers. On the right side, I would like to mention collaboration with Alex Avdev, who provided this test molecule for us. This demonstrates that now we are able to take into account different subtle electron structural and sterical effects during our pK calculation, which might result in different pK contributions and therefore different pK results. This also enhances the precision of our calculations. And another unique, not new, but unique feature is the tautomerization and the resonance effect. This means that regardless of which tautomer form the user puts in for calculation, we consistently always calculate the pK for the dominant tautomer form in that given solvent. In this example, it's the ketohydrazine form, which is the dominant tautomer form in water. The next change or smaller development was the so-called, we modified the log-P calculator methods. We wanted to simplify the log-P prediction methods, which were earlier available in the plugin. You can see a correspondence table between the older and the current available log-P calculation methods. The next one is tautomer generation, which was quite a crucial thing for us to do, and we also developed the available methods and the model behind the prediction. The main focus was to separate better the so-called canonical tautomer generation, which gives back a very good representation of the whole tautomer set of the molecule. And now we separated it completely with the so-called normal tautomer generation, which gives back the chemically meaningful tautomers. So now these two options are totally separated in the plugin. And here is also an example of the previous and the current behavior for this example molecule. And finally, I would like to mention two other plugins. The first is the stereoanalysis plugin. This plugin is able to find and also count the different types of stereo features in the molecule. It is also able to find the unknown stereo centers in the molecule and also the enhanced stereo centers. This tool can be very useful, for example, for virtual screening, when virtual screening based on different stereo features. And the last slide is about a new plugin which will be released in Marvin soon. It's called the hydrophile lipophile balance number prediction, or the HLB number. This is an important descriptor in so-called lipid-based system. So in any system, for example, in drug discovery, when lipid-based delivery could be an important factor. It could be also important number for describing detergents in cosmetics, for example. Yes, and this is only available now in our ChemAxon command line tool. So thank you for your attention. I ask you to come to our demo site so we can give you the details of the developments and of our future plans. Thank you very much.
About the solubility descriptor, and also valid for the other models, you have any distance, measure of distance to model when you have a new compound? We don't know if they are really similar or very far to the compound you use to train the model. So you have an indication about this?
For
tool is really sure or less sure?
Solubility.
For solubility, for example.
Yes, so we have benchmark results for the accuracy of the tool. Do you mean that?
More. So as you say, you have also an extra column saying to give in at least a percentage of relevance about the prediction.
Yeah. So
Is there it's implemented?
Yes. So we have for the prediction we have so-called qualitative and quantitative prediction. So we can give you an exact number, how much of that material can be solved, and we have also so-called qualitative. So it gives you whether it's highly soluble or not soluble. So this can be set in the tool separately. But we also have benchmark results. So if you are interested in that, we can give you the exact benchmark measurements.
I think in answer to the previous person, it would be helpful if you provided back the most similar compound from the training set to the molecule that was being predicted. So we can sort of see how similar. Do you have these kinds of functional groups in there or not? There's sort of from a user point of view, we don't know that.
For in general, similarity searches or?
No. So say I do a solubility calculation. You give me an answer.
Yes.
Okay, you give me a number. But I'd also like to see the structure of the most similar compound in your training set to the one that I put in, so that I'd get a feeling for, am I really off base or not?
Well, so we currently, so the training, we cannot train the solubility. So
well, you have. I mean, you have a model. You know what molecules are in the model. So I'd like to know the most similar molecule in your model to the one that I'm calculating today.
Yeah, it's a good suggestion, actually.
Oh, sure it is. I mean, he's got a database. You have a database.
Yes.
Okay,
Well,
we'll talk.
we will.
Yes.